Everybody, good morning, very good morning. Now, today we will see some technical things, a little bit technical things. Some we will discuss about some technical terms of computer. We will try to see that. What are the functions of those components of the in the computers. So we will start with different parts of CPU, actually central processing unit. Okay, we will start with different parts of CPU, and then gradually we will see some more technical things. We will not go into very detail because in our syllabus there is no such scope to go into very detail, as because we are actually management student, but still we need to know about computers, as because you cannot today you cannot do anything without help of computer. That's why this particular subject is here in your BBA syllabus, because computer science is like a it's like a salt. It's become like a salt, actually. As তুমি যদি নুন যদি তুমি রান্নায় না দাও, তো যে কোনো রান্নাতেই মোটামুটি যেমন নুন লাগে মোটামুটি, তো সেরকমই কম্পিউটার সায়েন্সও তাই এখনকার দিনে, বিকজ যে কোনো সাবজেক্টেই তোমাকে কিন্তু কম্পিউটার সফটওয়্যার, লিটল বিট অফ হার্ডওয়্যার নলেজ ইউ উইল বি নিডেড। সো দ্যাটস ওয়াই আমাদের এই সাবজেক্টটা, এবং স্পেসিফিক্যালি আমরা যেটা দেখবো, সেটা দেখছি আর কি, এই সাবজেক্টটা সেটা হচ্ছে এই যে how you can apply your computer knowledge in your business management. It's basically an application. That's why computer application, the name of the subject is. তো যাই হোক, তো আমরা শুরু করি। So basically we will start with central processing unit, or CPU. Now, the thing is, central processing unit or CPU is basically the brain of the computer, actually. Every process, every instructions, everything is executed by this particular component of the computer. It is very important component of a computer. It is very important component of a computer. That's why you cannot avoid this particular component. Without the help of this component, you cannot proceed. Okay, now this CPU is basically composed of three parts. The CPU is basically composed of three parts. That means within this CPU you will get three parts. One is known as control unit, second is known as arithmetic or logic unit, and third one is known as memory unit. So there are three parts: control unit, arithmetic and logic unit, and memory unit. Now if I start with arithmetic and logic unit, the arithmetic and logic unit, it is responsible for calculating all the mathematical operations. It is responsible to perform all the mathematical applications, whatever you are running by your computer. Okay, specifically I'm talking about the arithmetic unit, this particular part, because there are two parts actually. One part is arithmetic unit, another part is logic unit. As a whole, we are saying that arithmetic and logic unit. Now, arithmetic unit is responsible to perform all the mathematical related operations, whatever you are performing: addition, subtraction, multiplication, division, any operation actually, arithmetic related operation, it is done by the computer. It is done by this arithmetic unit. On the other hand, logic unit is something where all the logical operations are done. Suppose if I say that if I compare between two numbers, suppose I'm comparing between two numbers, Like I'm comparing 100 between 100 and 90. So I'm checking that is 100 is greater than 90. So that checking part, this part is operated by the logical unit. Okay, that is, yes, 100 is greater than 90. So suppose I'm saying that if 100 is greater than 90, then you do such and such work, and if 100 is less than 90, you do such and such, do some other work. So that is becoming a logical thing actually. That is becoming a logic, and we do this kind of we actually perform this kind of logical things in different computer programmings. So basically. So that is basically the logical part, and that logical part is handled by the logic unit. So there are basically two parts: arithmetic unit and logic unit. Next is that is basically the control unit. Now control unit is again another very important aspect. Control unit is again another very important aspect. Now in the control unit, actually everything is controlled by the control unit. Everything, every operations, everything is controlled by the control unit. Okay, so what is that? Actually, whatever you are performing, suppose we are providing input to the system, that input is processed by the arithmetic unit or by the logic unit or by any other components, and you are getting the output. Now all these things need a control, because computer system is composed of several parts. Now all these several parts are working together, and that's why we are getting the output from the computer. If the parts, if the different components of the computer, if they are not integrated, if they are not working together, if they are not worked together, then we will not get the desired output. Because each and every component has some specific functions, each and every component has some specific responsibility. So that's why it is very important to control all those parts. So as we are controlling all those parts, I mean, as this controlling is needed, that's why this control unit is there. So basically control unit control all these operations, or it controls all these components so that they can work together as an unit, as a single unit, okay, as a single unit. So that is basically the job of the control unit is. Another very important another important component within the CPU is known as memory unit. Memory unit is another very important component within the CPU. Now what is memory unit? In the memory unit, all the data which is needed, which is there for processing or after processing again, all this data that is stored in the memory unit. যে ডেটাগুলো তোমার প্রসেস করা দরকার সেন্ট্রাল প্রসেসিং ইউনিটের থ্রু দিয়ে, এবং যে ডেটাগুলো প্রসেস করা হয়ে যাচ্ছে, এই সমস্ত ডেটাগুলোকে কোথাও একটা স্টোর করতে হয়। So that's why for that CPU needs a separate memory. CPU needs a separate memory. There are different kinds of memory in the computer. You have seen that in the last class, like primary memory, secondary memory, and auxiliary memory. Now, memory unit here, that is basically the for CPU's own memory we are talking about. That memory is not falling under RAM or ROM or or cache memory and all that. Basically, this is falling under CPU. It is coming under CPU's own memory. We can call it CPU's own memory. And one such memory unit, I think you can say, there is a memory unit known as accumulator. Though it will be a little bit technical, I will not go into that detail, but accumulator is that kind of memory which is known as central CPU's own memory, which is known as CPU's own memory, that is known as accumulator. We will study a little bit about that later on today. So that is basically CPU's own memory is known as accumulator. Okay, that accumulator, but basically this memory unit, this particular memory unit, it stores temporary data. We call it temporary data. Now this temporary data, it is very much important to store while a particular data is being processed. So up to this part, এই অবধি তোমার জানলে হবে, এর বেশি আর দরকার নেই। So this is basically the function of the CPU's own memory, that is memory unit. So this is the three part of the CPU, arithmetic and logic unit. It is written over here, whatever the thing is. Now the different operations, if you see the different operations of arithmetic and logic unit, there are you will get primarily two operations, as I told you. One is arithmetic operations, another is logical operations. Now under the logical operations, there are different kind of operations, like we call it AND operation, OR operation, NOT operation, XOR operation, NOR operation, NAND operation. These operations have some specific type. Later on, if it is possible, I will discuss about these operations. I have not included here as because these particular things are removed from your syllabus in the last year. That's why I am not included these operations here. But still, I will discuss it if it is needed in the next class. But the logical operations, the name of the logical operations are these, like AND operation, OR operation. I can give you one simple example. AND operation means, suppose you are providing two inputs to your computer, X and Y. Suppose X has some value and Y has some value. I mean, the value will be obviously either 1 or 0, because whatever we are doing, we are interacting with our computer in the binary language actually. Okay, whatever we are doing, whatever we are performing, we are interacting our computer in the binary language, and the binary language has only two thing, 1 or 0. Either it will be 1 or it will be 0. Okay, there will be nothing. There will be nothing. So basically, our computer deals with ones and zeros at the end. Whatever you are typing, whatever you are writing, whatever you are getting, everything actually converted into 1 and zeros. So that particular language is known as binary language. Now, binary means two. There are two states. So 1 is one state, 0 is another state. So binary language. So suppose in the AND operation, we are providing two input, X and Y. Now, suppose X has value 1, Y has value 0. So ultimately, in the output by AND operation, we will get X into Y, or X and Y, we say. X and Y. So that means 1 and 0. So 1 and 0 will become 0. 1 and 0 become 0. So AND means, you can think for your simplicity that it's a multiplication operation. It is, but though I'm saying that it is not exactly multiplication operation, AND is separate operation, separate logical operation. But yes, it ultimately you will get the output as multiplication, but it will be in binary, 1 and 0, only 1 and 0, 1 1. It will be, suppose X and Y. So X can have value 1, Y can have value 1. Now suppose X can have value 0, Y can have value 1. Suppose Y can have value 1, X can have value 0. Okay, so like, or maybe both are zeros. So as per that, we will get the output. So that is basically AND operation. Similarly, OR operation, you can think it as the addition. But though again I am saying that we will not call it addition, it will be OR operation. NOT operation, just the reverse. If you provide 1 to your computer and if you use the not logical operator, so it will become 0. So it will be reversed. So these are some logical operations which is done by the logical unit in the CPU. Next, as I told you, the arithmetic operations. Arithmetic operations means multiplication, addition, division, whatever you say. These things. Another is bit shifting operation. Now, what is bit shifting? I will come into later. Bit shifting is basically, suppose you have a stream of bits. Suppose you have 8 bits, 1 0 0 0 1. Suppose like that. Now, either this bit can be shifted right, or this bit can be shifted left, or these bits can be rotated in a circular fashion. So we will see some of this example, that is bit shifting operations. So these things are done by arithmetic and logic unit in the computer, in the CPU. Okay. Next is control unit. Now, as I told you, control unit is very important because at the end of the day, you have to control all these components, There are several components, and all these components needs a control, so that they can work together, and give you a complete output. So control unit directs the entire computer system to carry out stored program instructions. So what is stored program instruction? Basically, whatever our computer is performing, it is performing based on our given instruction. Whatever our computer is performing, it is performing based on given our instruction. Like suppose whenever you are clicking on a particular mouse icon, you are double clicking on a mouse icon, that means you are giving instruction to your computer to open that program. So that's basically an instruction. Okay. So control unit directs the entire computer system to carry out that particular thing, that particular thing. Like that particular user wants to open this program, so you open this program. So that particular thing is done by the control unit. And it obviously it communicates both with arithmetic and logic unit and with main memory and all that, because as I told you, there will be main memory, there will be secondary memory, there may be auxiliary memory, there will be your CPU's components and all that. So all those components are working together. That's why you're getting this output. So it will communicate with all those components. Okay. So these are the functions of overall functions of control unit basically, and so these are the basic components. These are the basic components of the central processing unit or CPU. Okay, where control unit will be there, arithmetic and logic unit will be there, and memory unit will be there. And as I told you, here memory unit means CPU's own memory, which is more commonly known as accumulator. Short question can come that what is known as CPU's own memory, or what is the function of accumulator. We will see that, but it is you have to remember that it is the CPU's own memory that is known as accumulator. Okay. Next is we will see another very important thing that is known as machine instructions. Now, as I told you, whatever we are performing through our computer system, that is basically done based on the given instruction by us. Whatever instructions we are providing to our computer is just obeying that. Okay, like you are double clicking on an particular icon, so that particular program will be opened. When you are typing something and you are saving it, so whenever you are pressing on the save button, so it gets saved. That means you have instructed your computer to save that, that's why it is saved. So we are providing instructions. Now the thing is, these instructions are processed in the 4 steps. These instructions are known as machine instructions, and these instructions are processed in the 4 basic steps. What are the steps? The first step is known as fetch instruction from memory. Now the question is, which memory? So that will be basically RAM. Every instructions are basically stored in the RAM. So at first, whenever a CPU wants to execute a particular instruction, it will call that instruction, it will take that instruction, which is basically technically now known as fetch, from the RAM. So CPU will fetch the instruction from the RAM at first. Next, CPU will try to understand the meaning of that instruction. Next, after fetching that instruction, after getting that instruction, CPU will try to understand the meaning of that instruction, which is known as decode the instruction. CPU will try to understand those instructions, which is known as decode the instruction. And after decoding, that instructions will be converted into commands. After decoding those instructions, it will be converted into commands. Commands based on which, in the third step, CPU will perform that particular job. So commands based on which CPU will perform that particular job, which is step 3, which is known as execution of the commands. Now, very naturally, after execution of those commands, CPU will deal with different data, because ultimately through the commands CPU will process data. So as CPU will process the data through the commands, so those processed data needs to be stored somewhere after processing, so that user can get the output. So it needs to be stored somewhere, and that will be obviously again any component of the computer. নিশ্চয়ই এরকম হবে না যে CPU ডেটা প্রসেস করে তোমার খাতায় এসে লিখে দিয়ে গেল, এরকম তো হবে না। তো যা মেশিন যা করবে সেটা মেশিনের মধ্যেই রাখবে somewhere. It is not like that যে তুমি বললে যে তুমি এই অঙ্ক একটা ক্যালকুলেশন করলে, একটা বড় অঙ্কের ক্যালকুলেশন করলে, তো এরকম যে হ্যাঁ এরকম হলো যে কম্পিউটার থেকে একটা হাত বেরোলো, বেরিয়ে তোমার খাতায় ওটা লিখে দিয়ে চলে গেল। So that will not going to happen. So whatever CPU will do, it will store everything in the computer, within the computer. So for that again memory is needed. So that is the step 4, storing the results in the memory. Again that will be main memory. Actually whatever it is performing from the main memory. That's why that kind of memory is known as main memory. Whatever we are doing it from the main memory. And main memory is known as RAM. RAM is main memory. RAM, ROM, these are main memories. We have already seen those things in the last class. So this is basically the steps of the machine cycle. We call it machine cycle. Why machine cycle? Because for every instruction, this cycle happens. For every operation, this cycle happens. First step, we fetch the instruction from the memory. Second step, CPU try to understand those instructions, try to understand the meaning of those instructions. Third step, CPU execute the commands. And fourth step, CPU stores the result again into the main memory, so that user can get the result from the memory. So that is basically machine cycle is. Now if I come to the machine instruction, what is machine instruction? Machine instructions are basically some programs or commands written in some we can call it machine code, which is basically understandable by the computer. Now like for an example I can say binary code. Now what is binary code? The data written in the binary language. What is binary language? As I told you, the language which is written by 1 and zeros only. If you open that particular data, you will only see 1 and 0, stream of 1 and 0. So you will not get to understand that maybe. The machine will understand that. So whatever you are doing, everything gets converted into 1 and 0s. So that's basically machine code or machine language, whatever you can say. But to process those languages, we need to give some instruction to the computer. Otherwise, how computer will know that what you want to do with this data? So for that, you need to give some information to the, some instruction to the computer. So computer will process those instructions in these 4 steps. Step 1, it will fetch the instruction from the memory. Step 2, it will try to understand the meaning of those instruction. Step 3, it will execute those commands. That means it will perform the job. And step 4, it will store the result. So this is known as machine cycle. And overall, this thing is known as machine instructions. Hope you have understood. So that is written over here. Machine instructions has 4 main steps. In the fetching step, that means we are calling the instruction from the main memory. The processor fetches the instruction from the main memory address. That is in the RAM. It stores the address in the program. And now this will become little bit technical. There are some other issues, like there are some other components involved here, which is known as program counter, instruction registers, and all that. Actually, every instruction will have some address. Every instruction will have some address in the main memory. Otherwise, main memory is not also a very small area. It's a large area. So every instruction will have some address. Like we have our addresses. Our address of our house. So we know that this particular person lives in that particular address. So if I want to reach to that particular person, so I will search for that address. So in the same way, every instruction will have some address in the main memory. Okay, and that will be stored in the particular register. We call it register. We will come to the register, which is known as program counter. So program counter stores the address. More specifically, program counter stores the address of the next instruction that will be executed by the computer. What I said? Program counter stores, you can write it down, this particular thing, whatever I'm saying, you can write it down. Program counter stores the instruction which will be executed next by the computer. Okay, again I'm repeating. Program counter stores the instruction which will be executed next by the computer. So a short question can come, what is program counter? So program counter কি করে, CPU যে next instructionটাকে execute করাবে সেইটার অ্যাড্রেসটাকে হোল্ড করে। Okay, and another is like instruction register. In the instruction register all the instructions are stored. In the instruction register all the instructions are stored. Now it is written in the program counter. For the program counter also, look, the PC points to the next instruction at the end of the fetch operation. Okay, so that's the thing, it is written again here also. So this is fetch operation. Now decode, in case of decode, as I told you, basically CPU tries to interpret and try to understand the meaning of the instruction. Okay, so that is basically decoding operation. Next is execution operation, where CPU actually performing the job, and storing operation, where CPU storing the result. Okay, so that and with storing the result in the memory, if it is needed, it also displays the result in the output screen, that is on your monitor, or maybe in your via your printer. Via your printer, it will give you the output, or it will be shown in the monitor as well. So that's basically the 4 main steps of the machine instructions. And machine instruction is very important question. Okay, it may come, but what is the machine instruction? What is the machine cycle? We call it machine. These 4 steps, it is known as machine cycle. You have to draw this picture and you have to explain it. This picture is important. This particular picture of the machine cycle is important. You have to draw this picture and you have to explain those things. What is machine cycle and all that, right? Now, you can ask some questions if you have. Up to this, if you have any question, you can ask me. Do you have any question up to this particular? যতটুকু আমরা করালাম, যদি কারোর কোনো প্রশ্ন থাকে এই অবধি, you can ask.
Hello sir.
হ্যাঁ বলো।
স্যার বলছিলাম যে আপনি এখন বলেছিলেন মেশিন সাইকেলটা ড্র করে এক্সপ্লেন করতে হবে, তবে ওটা কি স্যার স্টেপ বাই স্টেপ এক্সপ্লেন করতে হবে, না মানে ড্র করে তারপরে মেন মেন পয়েন্টগুলো এক্সপ্লেন করতে হবে স্যার?
যা এখানে লেখা আছে সেটা লিখবে, ঠিক
আচ্ছা।
আছে? যদি মেশিন সাইকেল আসে যা এখানে লেখা আছে ওটাই লিখবে, তাহলেই হবে, তাহলেই হবে।
ঠিক আছে স্যার।
Anybody else have, if you have any question? Okay. So I hope you have understood this. Okay. So next we will see some more things like machine instruction. Now basically we the human being we cannot understand the language of the computer. So what we can understand? We can understand the English like language actually. We can understand English like language. We can understand English. So basically, whatever instruction we provide to our computer, we can provide those instructions via a language which is understandable by us very easily. So like when we write different programs in different programming languages like C, C++, Java, there are Python, Ruby, Basics, there are lots of languages. We generally write programs in English like language, right? Which is we are using the English characters, English letters, and we try to program. I mean, try to program the computer. Okay. Now this C, C++, Java, whatever programming languages we are using, this is basically known as high-level programming languages. High-level programming languages. Now the question is why? Why it is known as high-level programming languages? Now the answer is as because it is understandable only by the human being, not by the computer. That's why it is known as, or these programming languages are known as high-level programming languages. So, as I told you that computer do not understand these languages. Computer understands 0 and 1, which is basically you can call it machine language, machine instructions, machine code, whatever you can say. So there needs to be some conversion, obviously, from human understandable language to machine understandable language. So there needs to be some conversion. So in our next section, we will see which component of the system is responsible for this conversion. Okay. So I'm ending this session. Join in my next session. I'm providing you the link again, where we will discuss about these conversion procedures. Okay. So come to the next session.